Hello, everyone. We are Group 54, and today we'll be presenting our case study on the Walkerton water crisis, one of the most significant public health and engineering ethics failures in Canadian history. I'm Ashwini Nair. I'm currently pursuing my civil engineering, and I'm in my second year.
Myself, Risha. Currently, I am doing my master's in civil engineering with specialization in project management, and I'm a first year student.
Hello everyone, my name is Thoy Nguyên Triều and I'm a second year master student in chemical engineering.
Hello everyone, I'm Gulam Rabbani. I'm doing my Master of Engineering in Mechanical and Manufacturing Engineering.
Moving forward with our presentation, the Walkerton water crisis occurred in May 2000 in the small town of Walkerton, Ontario, when the drinking water supply became contaminated with E. coli and Campylobacter jejuni. Over 2,300 residents fell ill and 7 people tragically lost their lives. What made this incident even more devastating was the delay in warning the public. Despite of the early signs of contamination, the public notice was issued too late, allowing the outbreak to spread. The slide highlights how a combination of negligence, poor communication, and lack of accountability can turn a manageable issue into a fully blown disaster. When we look deeper into the crisis, it wasn't just a technical failure, it was also a human and psychological failure. Biases played a major role in shaping decisions during the crisis. For example, the operators showed overconfidence, assuming that the water was safe without proper testing. There was also confirmation bias, where early evidence of contamination was ignored because it didn't fit their expectation. These psychological traps led to misjudgments that delayed action, worsened the impact, and ultimately it costed a lot of lives. Understanding these biases reminds us that ethical engineering isn't just about following rules, it's about staying alert, questioning assumptions, and prioritizing safety above all else.
The Walkerton water crisis was not just a case of operator negligence, it exposed deep systematic and organizational failures in how Ontario managed public water safety. It is clear that multiple safety barriers had failed at once. My focus today is on the systematic issues, the weakness within the institutions, regulations, and oversight mechanisms that allowed third tragedy to happen. In the mid 1990s, provisional budget cuts severely weakened environmental protection programs. Focusing on systematic failures, the Ministry of Environment reduced the frequency of inspections, leaving local public utilities commissions like Walkertons to monitor themselves. There was also no accountability chain between local and provisional levels. No one ensured that operators were actually following safety procedures or not. Together, these factors created a system that looked functional on paper but was collapsing in practice. Communication failures made things even worse. When laboratories detected E. coli in the water samples, results were never promptly reported to the public health officials or to the public. Now, moving to the organizational and regulatory gaps. The water testing process depended almost entirely on operators' honesty. There was no verification or independent review of the data. Outdated regulations did not require source protection, meaning contaminated runoff could easily enter shallow wells like walkatrons. Training standards for operators were inconsistent. Despite of limited qualifications, staffs were responsible for maintaining chlorinizations and safety records. A culture of cost saving and efficiency replaced one of prevention and accountability. The government's focus on reducing spending undermined public health protection. Ultimately, Walkerton's legacy is a warning: when efficiency outweighs ethics, the system fails and lives are lost.
The Walkerton water crisis taught us powerful lessons about what it means to be an engineer. First, we learned that our work is about people, not just numbers. Every test, every system, and every design affects real lives. When engineers make mistakes or ignore problems, people can get hurt. Second, we learned that Safety can never be taken for granted. The operators in Walkerton assumed everything was fine because it had always been fine. We now know that if something looks uncertain, we must check, ask questions, and speak up, even if slow things down. Third, we learned that leadership means doing what's right, not what's easy. No one in Walkerton took responsibility when warning signs appeared. Good engineers lead by caring and stepping forward when something feels wrong. Fourth, we learned that being qualified is an ethical duty. The people running the system work outside of their training. We understand that it's okay to admit when we don't know something or to ask for help instead of pretending and cause terrible mistakes. Finally, we learned that design choices reflect our values. When cost or convenience comes before safety, people pay the price. As engineers, we must always decide with human safety first. The Walkerton crisis reminds us that ethics isn't just a rule, it's a part of who we are. It's about caring, asking questions, and putting people first in everything we build.
Uh, Now I will talk about the preventing future failures. First, engineering and systematic reforms. Uh, back to the Wakatan water crisis, one thing is clear: this tragedy could have been prevented with stronger systems and accountability. To start, every operator must be properly trained, certified, and continuously educated. Technical competency is the foundation of public safety. Next, real-time monitoring system that can act as our early warning eyes with sensors that immediately detect chlorine and bacteria levels and send alert before contamination spreads. We also need redundant safety barriers from protecting water sources to continuous treatment and testing. And beyond the technical side, transparency is the key. Making water quality data publicly available reveals trust and ensures that the communities are never left in the dark again. Finally, independent oversight and autonomous body free from the budget cuts or political influence is essential to make sure these systems stay accountable. Now, ethical culture and leadership for future engineers. Technology is not enough. What truly prevents another hackathon is an ethical culture. Ethical leadership means always putting people's safety above profit and convenience. It takes courage to make the right call even when it's unpopular. We must also create a space where whistleblowers are protected, where raising a concern isn't seen as disloyal but as a duty. Another important step is the community collaboration, especially with the indigenous and the local groups who are often most affected by the water issues. Their input brings valuable local knowledge and accountability. Lastly, as a future engineer, we should live by APEGA's principle: integrity, safety, and the protection of the public. By learning from the near misses and continually improving, we can ensure tragedy like Wakaton never happen again. Thank you everyone for your unwavering attention.